Hello, everyone. My name is Philip Churchley, and today I'll be teaching you guys a little bit about subtype polymorphism and virtual functions. So to help us out, I've written a little bit of code here, and the task that we have is to print out a summary of our school day using the teachers that we have. And they are actually classes that I've declared or I've made here in this header file. And we have a base class teacher with functions get name, get subject, and teach. And then we have a little bit of overloading going on here with derived classes, math teacher, science teacher, etc., who have more specific subjects and teaching lectures. So let's just see what happens when we try to compile the code and run it. So I got the names right, but it seems as if none of our teachers have subjects and they all have the same lecture. And it turns out that the reason for this is because of something called a static type and a dynamic type. So let's start with the static type. The static type of a pointer is the type that it's declared with. And you might think, oh, well, these pointers that we filled the array with, they're pointing towards science teacher, math teacher, and teacher, right? But actually, no, they are declared here as a teacher pointer. So if we go back to this function here and we look at this line in particular, we see this. And so this is what the compiler sees when it sees this teacher pointer. And it's a little confused because it sees these question marks. It doesn't actually know what it's pointing to, but it sees, oh, right there, it's a teacher pointer. That is its static type because it is declared as a teacher pointer. So what it does is it assigns the function here for teach as the what is declared in the teacher class. So that's where everything seems to go wrong. But luckily, there's a way we can fix this, and that is with the dynamic type, which is the type that the pointer is actually pointing to at runtime. So yeah, these pointers, James, Sophia, and Andrew, they are pointing towards a teacher, towards a math teacher, and a science teacher. And the way that we want to use those is by using what's called a virtual function. So I'll show you what that means using this green thing to show that now it's a virtual function. So when the compiler sees this, now it just says, oh, I'll wait, because it knows that virtual function is actually declared at runtime and not at compile time. So it waits, and then once runtime comes, we see, oh, math teacher, gotcha. And that is the dynamic type. And in this case, in this example, let's say it's a math teacher, but actually we know that it could actually be anything. And in this, as we iterate through this function, it could be a teacher, it could be a math teacher, it could be a science teacher, it could be anything. And that's why it's important that we figure this out during runtime. And so we see, oh, math teacher, and now we know, okay, let's assign this teach function from the math teacher. So to do this, we're going to switch over to our new updated code, which uses a new header file here. And it's very similar, except a couple things have changed. So we have this virtual keyword, which pretty much just says, hey, this is a virtual function now. And if you'll notice here, we also have this equals 0 semicolon. And that pretty much just turns these functions into what's called a pure virtual function, which means that they don't have any implementation. But base classes, which are here in this CPP file, derived classes, which are here in the CPP file, they can declare their own implementations. And they still inherit what's called the interface. And here we actually still have a implementation because we want our derived classes to share the same implementation, because the getName function will work the same for all of them. And then our CPP file for the derived classes is very similar, except we added this override keyword to like just tell the compiler, hey, this is overriding a virtual function, and they should always like match up like that. And the last piece of the puzzle is our teacher factory, which will always return a teacher pointer. So it won't actually be pointing towards the teacher, because actually we can't actually have teachers anymore, because once we have pure virtual functions, it doesn't make sense to have an instance of this teacher because it doesn't have any implementation. But that's fine because we never really want to use teachers. Most teachers have their subjects anyway, so having a teacher is pretty useless. And here, depending on what we put into the function, we will return new objects for math teachers, history teacher, EX teacher, and we use a new keyword here just so that they exist outside of the scope of the function, which also means that we need to clean up at the end. So looking here at what we have, we use teacher factory functions instead to return our teacher pointers. And let's see what happens when we do that. All right, so now it looks like it's working exactly how we want it to. And the reason why this is really important is because now we have this interface for teachers, which will work with no matter the the derived class that we use. So no matter what the subject is that the teacher teaches, our code will still work. And to show you what I mean is, let's say that James is now an EECS teacher. And the implementation for an EECS teacher is very different, but this code will still work. So let's recompile the code and run it again. And so in this case, we will ask a question, which is virtual functions depend on what type of the receiver. And I know that that is the dynamic type. And James says that I'm correct. So as you can see, EECS teachers work very differently and their implementation is different, but the function can still work. And that is why this is so powerful. So that is all. Thank you so much. I'll see you later. Bye.